percentage and
Yeah. Very
parts
good.
per million and molarity,
Yeah.
molar.
Yeah. Liquid solutions, concentration terms. And mass percentage. It is W by W percent, right?
Yes, sir.
Volume percent. It is V by V, right?
Yes.
And mass by volume percent. W by V percent. So is this your first class at Learnivio?
No, sir. I am taking chemistry class also.
From Learnivio only, right?
Yes, sir. Chemistry, maths, and physics also.
Okay. So we can, so you are aware of the basic things, right?
Yes, sir.
Okay. So, so you have covered up to which point?
Uh, so in the Learnivio classes, right?
Yeah.
So
Uh,
we have covered until freezing point.
okay. Very good. So we can, what we can do is we can have some problems. Okay. And with that, it will be a bit easier for us to know the things, right? We can do it more easily. Okay. So ppm is by mass and by volume. Okay. So basic definitions you all know. Molarity, you know. Molality, you know. Okay. And we will discuss it quickly. Okay. If in case if you want something, okay, uh, don't hesitate. Just tell me. Okay, we can revise. Okay. And normality is also there, right? Clear. So directly we can do some problems related to concentration terms. Okay, just a second. So you are preparing for JEE, right?
No,
What do you
sir.
understand? Yeah. So good evening, everyone. Let's start quickly. Okay. So just let me check just a basic question. 11 grams of oxalic acid. What is the formula of oxalic acid? In 500 ml of solution. Of density 1.1 gram per ml. Right? What is the mass percentage of oxalic acid? Is the question clear to both of you?
Yes, sir.
Yes, sir.
So just quickly tell me. $11 of oxalic acid, you take half liter of, it is there in the half liter of solution. Okay, half liter is 500 ml. Right? So you need to find out the mass percentage of oxalic acid, that is W by W. Okay, it is the mass of the solute divided by total mass, right?
Yes, sir.
Just quickly try it and tell me.
Recording in progress.
Yeah, what you are doing, tell me quickly. Yeah, am I audible to everyone?
Yes, sir.
Okay, Krishna, Mamuna, what you are trying, tell me quickly. Yes. Very easy question. You need to find the mass percentage. That is the mass of the solute divided by total mass. Okay, of the solution. Okay, and into 100. That's it. So what mass percentage of oxalic acid you are getting? Yeah, tell
So
me.
1.9.
It is how much?
So 1.9.
Yeah, you are very close to the actual answer. Yeah.
So
Sir, I got
1.96.
2%.
How much you are getting?
I got 2%.
Yeah, 2%. Yeah, 2% is the exact value. Okay. So percentage of oxalic acid. You guys know what is the formula of oxalic acid?
Is it C2H2O4?
C2H2O4. Yeah, it has two COH groups. Okay. It is a dicarboxylic acid. Why am I telling you? Because we have organic chemistry, so we will be discussing it in detail. Percentage of oxalic acid is a mass of oxalic acid. Okay, mass of oxalic acid is 11 gram. I'm writing it directly, divided by the total mass of the solution. And the total mass of the solution is not given because the volume is given. But we can find out the total mass of the solution by multiplying it with the density. So 500. This is, be careful. Always check whether it is solvent written or solution written. Okay, 500 into 1.1. It is 500 ml, right? And 1.1 density is gram per ml. Okay, so ml will cancel, right? So in the numerator you have grams of oxalic acid, in the denominator also you have grams of total solution. Okay, into 100, right? So I hope both of you did it in this way only. Okay.
Yes, sir.
Okay, very good. So 11 divided by 500. So this is the first basic question just for the warm up. Very easy question. Okay, into 100. So it will be, yeah, how much it will be. Just check it. Okay, this is 100 got cancelled. Okay, and this is 1.1, and 1.1 into 10 is 11. Okay, so 5 by 10, 5 into 2 is 10. So it is 2%. Clear? So I hope it is clear to both of you. Okay. So let's do one JEE mains problem. So I hope both of you are ready for it. Okay. And that is related to percentage. And it was asked in JEE mains. Right? So
Yes.
human body is there, and just like our body, okay. So it has a lot of elements in it. So the composition is given. I'm not writing the full complete language, just I'm writing so in order to save the time. Human body is there, and human body, uh, the mass percentage of various element, mass percentage of elements in human body are given. So oxygen is 61.4%. Okay. And carbon is 22.9%. Okay. Hydrogen is 10%. Okay. Nitrogen is 2.6%. So these are the various elements, main elements, right, present in a human body by percentage. Okay. The percentage composition is given. The weight of a healthy person is 75 kgs. Okay. Which a 75 kg person would gain if all hydrogen isotopes, okay, this is the mass which is written at the top. Okay, if all hydrogen atoms are replaced by deuterium. Okay, this is deuterium, the other isotope of hydrogen, which has mass twice the mass of hydrogen. Okay, and that's why the two is written. So what will be the gain in the mass of the person? Okay, in kgs. Okay, so is it 15 kgs? Is it 37.5 kgs? Right? 7.5 kgs? Or D, is it 10 kgs? Okay, this is one way of studying, as you guys are already studied the basic concept. Okay, so what I am doing is I'm directly taking the questions related to various concepts so that you can revise all the concepts. Okay, so in case if you need me to explain again, suppose if something we forget, it may happen, it is but natural, Vamsi and Memona. So you can tell me if something need to be revised or something, we can revise that also. And or the best way to revise something is through by doing the questions. Okay, so I'm adopting this method. Okay, in case if you have any suggestion or any recommendation, you can tell me. Okay, clear? So this question was there in JEE. Yeah, JEE mains 2017. Now you can have this question in the form of subjective also. in which you need to write the values. So how much will there be the change in mass of a person? Suppose if I'm 75 kgs and all the hydrogen atoms which are there in my body, okay, they are there in the water, they are there in the glucose, okay, all the molecule which contain hydrogen atom, you take that hydrogen atom out and you put deuterium in place of hydrogen, okay, clear? So how much mass of my body is going to increase? Is it clear, the question?
Yes, sir.
Okay. So let's do it quickly. Yeah. Yeah, Memuna, what you are doing, tell me. Are you getting close to the answer?
Sir, is it option A?
Yeah, exactly. It is option A. And Vamsi, what about you?
No, sir. I am confused, sir.
Yeah, actually, sometimes what happens is more than what is required is given, just so to create more confusion. Okay. Actually, a lot of data is given, but this data is of no use for us. Actually, the main data which we need to look at is the percentage of hydrogen. Okay, that is 10%, right? Why I need to look at only at the hydrogen atom? Because the question is related to the change of hydrogen atom to deuterium atoms, okay, which is the heavier isotope of hydrogen. So what I did, so mass of H is equal to 10% of the mass of the total human body, right? So 10% of 75 kgs, right? So it is 7.5 kgs. This is the mass of the hydrogen, all the hydrogen present in the human body whose mass is 75 kg. 7.5 kg is the amount of hydrogen. So you remove it, okay? And just let me check, maybe this may not be the right answer. Just we need to look at it again, I think. Okay. Even I also don't remember the answer. I am solving it like you. So what you did, you replace the hydrogen atom and you by deuterium. Okay, so the mass will become double. So initially mass was 75 kgs. Okay, you removed hydrogen. Okay, 7.5 kgs is removed from the 10% is removed, and that 10% instead of that, the double the mass of the hydrogen was added. Okay, 15 kgs were added. Double the mass. Why double the mass? Because the deuterium is having mass twice the mass of hydrogen. Is it clear?
Yes, sir.
So actually, this question can be asked in many ways. What will be the gain in weight? Okay, that actually the 7.5 kg has been replaced by 15. So Memuna told 15, and okay, so that 15, yeah, that is the change, amount of change. Okay, and how much gain will be there in the overall mass? Femini, are you getting it? What the question is asking? Though your calculation is correct, but you need to know, you need to answer very precisely on the basis of the exact thing which is being asked in the question. So how much gain will be there? Tell me. Getting it? Weight which a 75 kg person will gain. Vamsi, is it clear?
Yes, sir.
Okay, Memuna, is it clear? So answer will be 7.5 kgs. Okay. Actually, the total the mass of deuterium which was introduced was 15 kgs. Okay. So what is asked actually, you need to answer that. Okay. Initially, I have not read the question properly. So later when we checked the weight which a 75 kg person would gain, okay, the gain will be of 7.5 kg. So the answer is going to be C. So I hope it is clear to both of you, right? Okay. So just these kind of mistakes may happen. Okay. So be careful regarding that. Okay. And let's move to another question. It is related to ppm. So what do you understand by ppm? Can you tell me quickly? Yeah. ppm is actually percentages, how many grams are there in 100 grams. In 100 parts by mass, how many grams are there of a component, that is its percentage. Okay. And in ppm, actually you take 1 million parts, 1 million grams. So of a component, how many parts of a component by mass are there in 1 million grams? Okay, that is actually the ppm of a substance. It is used, when it is used ppm. Yeah, can you tell me?
Sir, when there are extremely small components
Yeah,
present in.
suppose if, yeah, exactly. Suppose if the thing is present in a very small quantity and you are not able to find it in percentage. Percentage means out of 100 gram, let's say. But the thing, amount of that thing is so small that you will not be able to get anything in percentage. So you take a large sample, okay, 10 to the power 6 gram. So in that it will be significant. Okay. So that is called ppm. Okay. So let's quickly move to the next question. 400 grams of pond water has 3.5 ppm dissolved nitrates. Nitrates which are dissolved are this much. So find the actual mass of nitrates. Clear? I hope the question is clear and it is quite easy, but still it may go wrong just because of the units. Okay. So it is 14 milligrams. Option B, is it 1.4 grams of nitrate which is there? Okay. Or is it 1.4 mg milligram? Okay. Or is it 14 grams? I hope you are getting what I'm trying to ask. Yeah, just do it quickly. Yeah. What will be the answer? Yeah, tell me quickly. Vamsi, Baimuna, any? I hope you are solving it very quickly. Yeah. What answer you are getting? So ppm is 3.5. So as per the formula, ppm is 3.5. What is the formula for ppm?
Sir, is it
3.5.
option A?
Option A. And Memuna, what you are getting?
Sir, same.
Option A. Okay, let's check it quickly. So 3.5. So ppm, the formula you guys know. So ppm is equal to mass of the component divided by total mass into 10 to the power 6. Okay, just like the percentage where you multiply by 100. Okay, that fraction by 100 in ppm, you multiply it by 10 to the power 6. Okay, so mass of nitrate divided by total mass. Total mass is 400 gram. You need to know that the units of mass should be same in the numerator as well as in denominator, into 10 to the power 6. Okay, so this is how much? 3.5 into 400 into 10 to the power, this is 6, and it will come this side, so it will be minus 6 grams. Okay, mass of nitrate. Okay, so you need to solve this one. So 3.5 into just we can remove 1 0 and we can make it 35, right?
Yes, sir.
35. Yeah, 35 into 2 is 70 and 70 into 2 is 140. So this is how much? 35 into 4. Okay, 35 into 2 is 70, 70, 140, 1400. This is 1400. Okay, that you did very correctly. Okay, and there is 10 already, 140 and this 10. Okay, into 10 to the power minus 6 gram. What is milligram?
10 to the power minus 3 grams.
Yeah, 10 to the power minus 6. So this 10 to the power minus 6, what I do, I will split into 2. 10 to the power minus 3 and 10 to the power minus 3. What is the purpose of my splitting? My purpose is this 10 to the power minus 3 grams, I can write it as milligrams. Okay, mg. mg is 10 to the power minus 3. And this 10 to the power minus 3, I can simplify, I can multiply it with 1400 and get it simplified. So actually it is minus 3, so I need to move the decimal 3 places towards the left hand side. So it is 1.4 milligram. Got my point? So you guys know how to do it. Okay, it is very simple question, everything you know. But even if we know, there can be some mistakes, like in just because we are doing it very quickly, so we may go wrong. Okay, like this is the mistake of the unit, right? So you all of you figured out that the answer will be either 1.4 or 14. Okay, so but and the unit you need to cross verify. Okay, so it is 1.4 milligram. Okay, so the right answer is option C. Is it clear? Any doubts in this?
No, sir.
Okay, very good. So yeah, and the other thing is the mole fraction. Mole fraction is also used to express the concentration in terms of mole. Okay, So mole fraction is the mole of a component divided by total mole of all the components which are present in the solution, and you may be asked to convert the mole fraction into mass percentage and mass percentage into mole fraction. Okay, so you can do that also. That is very simple. Okay, so let me ask you one question. Okay, and that is interconversion of mass percentage to mole fraction. A liquid mixture of gases. Okay, actually you liquefy gases, and that liquid mixture of gases has oxygen. Okay, and it has 32% of oxygen. Okay, by mass. Okay, and it is having methane, that liquid mixture, liquid methane, CH4. It is 16% by mass. Okay, and carbon monoxide, which is equal to 52% by mass. Okay, the mass percentages of these three gases actually which are in the liquid form is given. So what is asked is you need to find out the mole fraction of methane. Clear?
Yes, sir.
The question is very simple, but it is very important for us to understand the question thoroughly. Okay. Don't be in a hurry to solve the question. First understand it. You have a lot of time. Okay, so you can spend your time in understanding the question. Okay, clear? Because suppose if we read and understand it in an improper way, we may not get the right answer. So first step is to understand the question thoroughly. Yeah. Yeah, what you are getting, tell me. It is bit lengthy with respect to the calculation. Yeah. Any idea? Mole fraction you need to find out of the methane. Okay. So in not only in this chapter, though I am starting with this chapter, but everywhere in other chapters also you will encounter the same condition where the percentage is given. Okay. So for simplicity, what I try to do is I take the total mass as 100 gram.
Sir, is the mole fraction 0.27?
Yeah, very good. Yeah, the mole fraction is 0.26. right?
Yes, sir, 26.
Yeah, Memuna, what you are getting?
Yes, sir. Even I got 0.26.
Okay, very good. Okay, so I assume the total mass to be 100, and this is now it is very simple. So, 32 gram oxygen. Okay, so it is how much? 1 mole of oxygen and 16 grams of methane. It is also 1 mole. And how much carbon monoxide is there? CO. It is 52 grams. Okay, and divided by 28. So you will get it moles. Okay, so the mole of methane divided by moles of all the component. So answer is going to be chi. Mole fraction is represented by a letter, Greek letter chi. CH4 is equal to 0.26, right? Okay, so I hope the method and all is clear. In case if you have any doubt, don't hesitate to share it with me anytime. Okay, so one more question from JEE mains. Okay, we can do that, and that is related to this mole fraction only. Okay, mole fraction and molality. Okay, so we can do the molality and molarity also, then we can try it. Okay, so what do you understand by molarity? Just quickly tell me.
So number of moles per 1 liter of solution.
Yeah, how many moles are there in 1 liter of total solution? Okay, total solution is there. How many moles of solute are there? That is the molarity. It is represented by capital M. So when the molarity is going to change, just you need to answer. Okay, suppose if I take a solution in a beaker. Okay, if I'm taking a solution and if I divide it into two by pouring some of the solution in another beaker, is the molarity going to get affected?
Yes, sir.
So if I take the same solutions and I divide it into two, Memuna, what you think about
No,
this?
I think it will remain the same.
Yeah, molarity is going to remain same actually. It is just like, suppose if you have made a lemonade or a sugar syrup, okay, some drink, and suppose if you share it with your friends, okay, you divide it into two glasses. That doesn't mean that the other person will have the less sugar in its solution or more sugar. Okay, the sweetness is going to be same. Sometimes we try to taste the uh, syrup which we have made, okay, or the solution which we have made. So we take it with the help of spoon. So the sweetness of the solution which is there in the spoon, that is same as that of the original solution. It is because the volume get halved or the number of moles of solute also get halved. Okay, if I divide it into two, the volume will be half. Okay, the volume of the solution will become half because I have divided into taken it into two beakers, but the moles will also get distributed and they will also get half. So molarity is going to remain same because molarity is moles per unit volume. So half n by 2 moles and v by 2 volume. So by 2 will get cancelled. So molarity is going to remain same if you divide the solution into two. Okay. Another thing is, suppose if, can you tell me what is the biggest drawback of molarity?
So it is temperature dependent.
Yeah, it is temperature dependent. Suppose if you keep it in hot condition or keep it in a cool condition, so the molarity is going to change because the volume is temperature dependent. Okay, so as you told me, you guys are studying freezing point depression. So there the concentration term which is used is not the molarity. Okay, it is molality. Clear? So now I hope it is clear that why molality is used, not the molarity. Okay, so because molarity changes with temperature. It fluctuates slightly with temperature because the volume can increase or decrease. right? Changes with temperature. So molarity is not considered as a good unit whenever you are doing an experiment in which there is a fluctuation in temperature, because molarity may change slightly. Okay, and definitely the molarity will change if you add some solvent. If you add some more water, the solution will become dilute, so molarity is going to decrease. Or if you evaporate some of the solvent by heating the solvent, it evaporates, so the solution will become more concentrated, so molarity will increase. Okay. So, and what is the formula which relates the molarity of the mixing of two solutions? That you know? Yeah, tell me. Suppose if you have solution which has molarity M1 and volume V1. Okay. If you have solution which has molarity M2 and volume V2.
So M1 V1 is equal to M2 V2.
Yeah, and you mix them up, and that is a resulting solution of molarity M3. And the volumes, I am assuming that they are same, added. Okay, V1 plus V2. Okay, so the molarity is M1 V1. Why you are doing this? M2 V2. Actually, molarity, if you multiply by volume, you get the moles. So moles of the solute are going to remain same. So these are the moles of the solute present in the first solution. These are the moles of solute present in the second solution, is equal to new molarity into total volume V1 plus V2. Okay, that's how you are going to find the molarity. Okay, but be careful. If they are both bases or if they are both acids, okay, having same type, having same that means they are giving same H plus ions or same OH minus ions. Okay, then only you are going to put the plus sign. But if you have that one acid, another base, then you will subtract the moles. Okay, because acid and base actually they cancel each other. They make a salt, and the resulting solution can either be acidic or it can be basic, depending upon whose moles are taken in excess. If the acid moles are taken in excess, the resulting solution is going to be acidic. Or if the base moles are taken in excess, then the resulting solution will be basic. Okay, clear? So very easy question that was there in JEE mains related to this. Very easy question, and I hope you will be able to do it. 10 ml of 2 molar NaOH is mixed with 200 ml of 0.5 molar NaOH. Okay, so what is the final molarity? I hope you understood the question. This was there in JEE means 0.57 molar. Is it 5.7 molar? Or is it 11.4 molar? Or is it 1.14 molar? Yeah. Getting it?
Yes, sir.
Very
Just
easy. Yeah, very easy. Not many twists and turns, straightforward question. What's the answer going to be?
So A.
Yeah, it is. Mamuna, what you are getting?
Yes, sorry.
Yeah, 0.57. So just you need to be careful regarding the volume. It should be taken in liter. Okay. So it is 1 by 100 liter. Okay, you need to divide it by 1000. Yeah. Okay. So this is the basic, very basic problem, and you did it correctly. That's good. So let's take some other problem which can be little bit. It may require little bit more calculation. Okay, related to molarity. Okay, and what are the things which are required, that we will discuss. Okay, this is also asked, and this is the question which is asked in JEE Mains 2012. At that time, it was AIEEE, but it is the such pattern questions are asked every year. Okay, they change the data, they change the name of the solute, and they ask in some examination or the other. Okay, so this pattern of question is very common. Okay, related to molarity. Okay, so the density of the solution, the density of the solution prepared by dissolving 120 grams of urea. What is the molar mass of urea? It is 60 gram per mole. Okay, so density of the solution prepared by dissolving 120 grams of urea in 1000 grams of water. This is just the solvent, not the solution. Okay, be careful. And the solution which you get has the density of 1.15 gram per ml. This is the density of the solution, which resulting solution which you got. So what is the molarity of this? Okay, this question was there in 2012, but every year it appears almost, okay, in one form or the other. I can give you the hint, options, not the hint. Okay, so 1.02 molar, or is it 2.05 molar, or is it 0.05 molar, or is it 1.78 molar? So yeah, you can try first, then we can discuss quickly. Hmm. So you need to keep one thing in mind, what you want. You want the molarity. Okay. So you need moles of urea in the denominator. That is very easy. And in the numerator, you need to have moles of urea, and in the denominator, you need to have volume of solution, complete solution. Okay, that is the molarity. Okay, so I hope you understood this. And so quickly tell me what answer you are getting. Yeah, moles
Sir,
of
is it
urea are
option number B?
option B. Yes, 2.05 you are getting.
Yes.
Okay, very good. So numerator is clear. You don't need efforts to get it. Just 60 grams will make 1 mole urea. So 120 gram will make 2 moles of urea. Okay. So 2 is there. Pharmacy, clear?
Yes, sir.
And the volume. For volume, what you need? Volume of the solution. It is the volume of the solution. So don't take the volume of water only. Right? Don't take the volume of water. You need the volume of the solution. So volume is V solution. How can you get? It is a mass, total mass of the solution divided by density. Mass in grams and density in gram per ml. Okay, if it is there, so gram will can cancel, you will get the ml. Okay, if it is ml, you need to you need to divide it by 1000. Okay, to make it liter. That's it. So 1000 will go in the numerator, so 2 into 1000 divided by volume of solution. Volume of solution, how you got? By taking the total mass. Total mass is 1000 gram of water and 120 gram of urea. So 1120 grams is the total mass of the solution divided by what? Divided by the density. 1.15 gram per ml. Okay, so you need what? You need to divide it by 1000. So I've already taken 1000 in the numerator. Is it clear? So it is going to be 2 into 100. It is 200, right? Divided by 112, and this is 1.15. It is 2.05. Pamsi, is it clear?
Yes, sir.
Okay. The next question is very recent, 2020 JEE mains question, and it was there in the integer type. Now you have the integer type just like in JEE advanced also. So same questions. Sometimes they are very easy and sometimes they bit tricky, little bit tricky. But if your fundamentals are clear, you can do it very quickly. This is also related to molarity. Okay, and just let me tell you this. In this, actually in this also some density is given and the mass percentage is given. Okay, So you need to find the molarity of HNO3. HNO3 is nitric acid. You might have seen in lab. Okay. Molarity of HNO3 whose density is 1.4 gram per ml. This is the density of the complete solution. Okay. HNO3 solution. Density, it is the density of the complete solution. Okay. And the mass percentage is the solution has mass percentage of 63%. Mass percentage of HNO3 in that solution is 63%. Okay. So the molarity of HNO3 solution with density is 1.4 gram per ml and mass percentage of HNO3 is 63% is dash molar. Okay. You need to tell me the molarity. HNO3 molecular weight is given. It is 63. Subjective question. So you need to mention the data. No options are given. Clear? So I hope question is clear. So same way we can do this. So I told you we get a lot of questions related to this. Okay. Yeah. So keep in mind one thing, that what you want. Okay, you want molarity. Okay, what is given? Percentage is given. Mass percentage is given. That is the mass of HNO3 and divided by total mass. Mass of HNO3 in sorry 100 grams of solution. That also can be interpreted from the mass percentage. Okay, I always do wherever the percentage is there. In order to make my calculations and my life easier, I take the total mass to be 100. Okay, that helps me a lot. Okay, so you
Sir,
can
is it
also do that.
14 moles per liter?
It is
14 moles per liter.
yeah, it is 14 moles per liter. 14 m. Okay, Memuna, are you getting it?
Yes.
Okay, so how we did? So what is the data? It is 63% HNO3. Vamsi, how you did it? Tell me.
It's just like the data is given like 63 percentage so of HNO3, so we can write as 63 grams of HNO3 in 100 grams of solution,
Yeah,
and we can substitute the value.
yeah. So this is 63 gram because the molecular weight is 63. So 1 mole. That is, so molarity we need to have 1 mole. Mole in the numerator. And the denominator you need to have the what? In the denominator you need to have the volume. So volume also you can find out. Okay, 100 gram is there of the solution. So 100 gram of the solution, total solution is there. You can divide it by the density. Density is 1.4 gram per ml. Okay, so this is going to be in ml. Gram will cancel. This will be in ml. So you can divide it by 1000, and that 1000 will come in the numerator to make it liters. Okay. So very simple question. 1.4 will come in the numerator and it will be multiplied by 10. So it is 14 molar. Okay. So very good. These are the basic questions. So the next unit which we use is molality. Okay. So what is the definition of molality?
So number of moles of solute per 1 kg of solvent.
Yeah, it is represented by small m. Number of moles of solute divided by you take only the mass of the solvent. Okay, that's it. Okay, so it is easier for us to calculate the molarity if you have some solute and if you have some solvent which is given prior to mixing. So you have the mass of the solvent, you have the mass of the moles of the solute prior to mixing them. You can, they are separate, solute and solvent, so you can have the mass of the solvent separately. So how many moles are put into that solvent, that given mass? Okay, that is molality. And the main advantage of the molality is it is not going to change with temperature, that you know. Okay, because in that, unlike molarity where we use the volume of the solution, here we are using the mass of the solvent, total mass solvent, okay, in the denominator, and the mass doesn't changes with the temperature. So the molality is going to remain fixed, and that's why the freezing point depression and the boiling point elevation are using molality. Okay, clear? So let's do one question, and that can help us to understand better. This is also JEE question only. So I'm taking just JEE questions so that you can have idea and more practice. If you have 20% mass percent of Ki aqueous solution, okay, so what is the molality? Molar mass of Ki is 166 gram per mole. Mass percentage is given. Okay. So this is related to conversion of mass percentage to molality. I'm giving you the options. .08 molar, or will it be 1.48 molar, or will it be 1.51 molar, and the last option 1.35 molar. Okay. So again, the percentage is given and I can take the total mass to be 100. And that can make our life very easy, right? Okay, yeah. These are, Memuna, these are actually common questions because JEE mains and NEET questions. The same type of questions are asked in NEET. I can take the NEET questions also, no problem with that. Okay, because these are the basic questions which everybody asks. Okay, in JEE mains or NEET. Okay, so you don't have to worry about it, right? Though I have taken JEE questions, I can take NEET questions also, not a problem. But these same concept, these are actually evergreen concept. Okay, and everywhere you have these kind of concept questions. Okay, in every year also. Okay, and all some examination on the other, you will have these kind of questions. Okay? So don't worry about it. I will take care of that. Okay. Here, if there is something special, I will take and I will take some examples of NEET also, not a problem. Right?
Okay, sir.
Yeah. So this is also a common pattern. So percentage is given and molality is asked.
Sir, is it the third option?
It is the what you are getting 1.51. Yeah, third option. So how can you do it? Yeah. Tell me quickly. Ravina, are you getting the answer?
Yes, sir, I'm trying.
Yeah. And Vamsi, what you did? You can explain me.
Yes, sir. First of all, I took the moles of Ki by dividing 20 by 166, and
Oh.
then so I substituted in the formula of molality. Then I got like 20 into 1000 by 166 into 80. I solved
Yeah.
it at 1.5.
Hmm. What actually I should say is that be very simple, okay, and don't try to remember complicated formulas, okay. So just the mass percentage is given, W by W. So of Ki. So it is, and because the percentage is given, what I do always, I take the total mass 100. Okay, so 20 grams of Ki. 20 gram of Ki is there in 100 gram of total solution, right? So that's what the percentage means out of 100. Okay. Okay, now what I need in the numerator, I need molality. In the numerator, I need moles of Ki, which I can get very easily by dividing 20, which is the mass of Ki divided by its molar mass 166. In the denominator, this is the total mass of the solution. Okay, so I can express it in this way also. So Memuna, do you agree with this now, whatever I am writing?
Yes, sir.
So 20 gram plus 80 gram. Okay, so what I can do is, so I clearly I'm getting the mass of solvent, because in the molality you need the mass of the solvent only, not the total solution. You need just the solvent mass. Okay, So this is 100 grams. So 100 gram has 20 gram Ki, and who told me? Because it is 20%. Okay. So in order to get to the molarity, so actually 20 gram Ki is added to 100 gram of water, and that will make the total mass to be 100, and that will also give us the mass percentage of Ki as 20%. Okay. So it will be how much? 20 by 166 divided by 80 gram of water. 80 gram, we need to divide it by 1000 to make it kg. Okay, this will be the molarity of Ki. So moles of Ki divided by mass of solvent only, water only. Okay, in kgs, in kilograms. Okay, so I hope this is clear. That's how you are going to do it. Okay, so this 0 will get cancelled. 20 by 18, okay, into 166. 166 will come in the denominator. Okay, and into 100 will go to the top. Is it clear? Okay,
Yes, sir.
so you will be getting 1.51 as the answer. Okay, very basic question, very used everywhere. Okay, no need to remember the formulas, right? Because actually what may happen is in the formula sometimes you need it will life will become more complicated if you remember the formulas, because sometimes you may get confused or you may forget, it puts unnecessary pressure. Okay, so this is the way I try to do the problems. Okay, take the mass percentage, that's it. Okay, if the mass percentage is given, take the total mass to be 100 and remember what is given and what is required. So accordingly work one by one. Okay, so I took the moles of Ki initially, the mass 20 gram divided by molar mass, so you get the moles of Ki. So numerator is complete. Denominator, I needed the mass of water only. So this 100 gram was the total mass. I subtracted the mass of Ki 20 grams, so I got 100 grams as the mass of water only. Okay, I converted it to kgs. Okay, so that will give me the molality of Ki. Clear? So I hope it's very clear. And let's do one more problem of molality. And it is related to mole fraction. Okay, it is one and the same thing. Actually, suppose if something is given in fraction, what I try to do is I take total as 1. Fraction means out of 1. And if something percentage is given, I take the total mass as 100. Okay, just few simple things I adopt and which makes my calculation very easy, right? So the next thing is, next question, mole fraction of a solvent. And be careful with the 3 words. Actually, these 3 words, if we don't read them carefully, they can make our life difficult. Okay, so mole fraction of a solvent in aqueous solution. Aqueous solutions means it is the solution of water, and this is the mole fraction of the solvent, only solvent given. Normally the mole fraction is expressed for solute, okay, the substance which has dissolved, but in this case it is for the solvent. Aqueous solution of a solute is 0.8. Okay, What is the molality of this? Yeah. Yeah. Memuna, are you trying it?
Yes, sir. Sir, is it 13.88 mole per kg?
Yeah. It is 13.88. Exactly. Very good. Pamsi, what you are getting? Tell me.
Sir, I got lost, sir. Can you help?
A mole fraction of the solvent. And mole fraction of solute. Will be equal to 1. That we know. Because some of the fractions will be 1. So these are the fractions of the mole. Okay, we need to work on the solute. Okay, but this is given actually 0.8. So the mole fraction of the solute is 0.2. Okay, so fraction means out of 1. So solute out of 1 total moles, if you take 1, okay, 0.2 moles will belong to the solute. That's it. So it means 0.2 moles for solute and 1 mole, because it is fraction total, right? That is for solute and solvent both. And what I need only molality. Okay, so 0.1 mole total means 0.2 were there for the solute, that we already know, and 0.8 were there for the solvent mole. Okay, so 0.2 moles of solute divided by total moles were 1. Okay, but out of those total mole, 0.8 moles were there for the solvent. But as per the definition of molality, I don't need the moles of the solvent. I need its mass in kgs. Okay, so 0.2 are the moles of the solute, that is okay. But 0.8, 0.8 moles of the solvent, right? So I need to multiply it by molar mass of the solvent in order to get the mass. So molar mass is, it is aqueous solvent. Okay, so it is water. So it is 18, right? 18 gram per mole, 0.8 mole for the water, and 18 gram per mole means it is these many grams. Okay, divided by 1000 to make it kgs. Okay, So how you did, Mamuna? Is it the way?
Yes, sir.
Okay, 1000 will come at the top, 0.2, and this will get cancelled, 4, okay, into 18. Okay, so this is how much. Pamsi, have you understood it?
Yes, sir.
2, 9, and 2, 5. Yeah, right. So it will be 13.88. Very simple. Okay. So what do you understand by? So sometimes not only that you have every time you have these numericals. Okay, you have some basic questions also. The basic questions are related to the concept which we discussed. Okay, in NEET actually sometimes they ask very basic questions, but sometimes the question can be difficult also. The fluctuation is more. Okay, so basic questions actually they just ask, they just write few statements that which are representing the characteristics of molarity. Okay, so which concentration in term is going to change with temperature? Is it the mole fraction? Mole fraction, is it going to change with temperature? No, because moles are going to remain same. Is it the mass fraction which is going to remain that change, which is going to change with temperature? No. Molarity, is it the molality which is going to change with temperature? No. Only the molarity is going to change with temperature. So NEET, sometimes we have these questions which are very basic, but sometimes the questions can be very tricky also. Okay. I remember till now we have not discussed that. Okay. I remember actually a paper in which actually there were some questions which were not even asked in JEE Advanced. Okay. But there were few questions, but many questions were very simple and some questions were very difficult. Okay. So we need to cover more wider areas. Okay, as far as NEET is concerned, right? Clear? So yeah, so let me talk something about normality. So what do you understand by normality? What you know? It is represented by capital N. Yeah, tell me, Memuna and Vamsi, what do you understand by normality? Yeah, Krishna, tell me. Yeah,
So it is the number of gram equivalents divided by the volume of solution.
yeah, it is the number of equivalents. Of solute divided by volume of solution in liters. So how many equivalents are there? Okay, so actually I remember that this equivalent thing always was very tricky for me. Okay, when I was preparing for my JEE examination, it always uh, I found it difficult. Okay. So let me be very simple. Okay, in explaining this, actually, suppose if you take 1 mole of H2SO in 1 liter. Okay, its molarity is going to be 1 molar because you have taken 1 mole H2SO4 in 1 liter. Is it clear?
Yes, sir.
But actual thing which is working in the solution are not the moles. The actual thing which is working is of H2SO4, because I have used H2SO4 as an acid. It is a famous acid. So it in acid-base reactions, okay, though it undergoes redox reaction also, okay. So in acid-base reaction, actual thing which is working are the H plus, right? So actually it is it is giving 2H plus. Okay. So I need to, so suppose if I'm doing acid-base calculations, and if I just relied on molarity, okay, I may go wrong, because even if it is 1 mole, but it is giving 2H plus ion, means it is equivalent to 2, because this one is equivalent to 2, okay, because it is giving 2H plus ion, or I should say the basicity of this acid is 2, okay. So it is actually 2 equivalent, okay. So suppose if we work only by mole in H2SO4, sometimes we need to be very careful. We need to take into account that this 1 mole will give 2 moles of H plus ions, and accordingly we have to do the calculation. But if we are using normality, it is very straightforward, because we are talking in terms of equivalent. Okay, so whatever we are putting in the solution, the solute, and not counting its mole, we are counting its equivalent, and we are trying to say it is equivalent to how many. Okay, clear? So that is means we are talking in terms of the actual things, okay, which are going and doing the reactions. Is that clear? So it is equivalence. I hope you understood. So suppose this equivalent is like can be found out by many ways. For acids, it can be found out by counting the number of H plus ions which one molecule of acid can release. For bases, it can be found out by counting the number of OH minus ions, okay, which are released by one base molecule, okay. So it is equivalent to how many, okay. Or in redox reactions, we calculate equivalence depending upon the number of electrons, okay, which a substance is going to gain or lose, okay. So in terms, when we are doing the reaction, it is not the moles of this one and moles of the that substance are going to be equal while reacting. It is the number of equivalents which are going to be equal. So it is important for us to express something in terms of equivalent instead of moles. The equivalents will give us the more real picture, okay. It will give us the concentration of the actual thing. Suppose if the H plus is there, actual H plus concentration is how much, okay. That is, so that's why it is a need, there is a need to express these concentration in terms of equivalents per liter. That is called normality. Is it clear? So just quickly, because the time is already up, just we will do one question. So I hope you understood the idea, okay, of equivalents, right? 49 gram of H2SO4. What is the normality in 1 liter? Just last question. Yeah, what is the normality of this solution? Quickly, we can do it. Yeah. So molecular weight is either you can find directly the number of equivalents, or if you are not satisfied with the equivalents, you can find out the mole and you can convert them to equivalents, okay. And with that, you can find out how many equivalents are there. So molecular weight of, yeah, Vamsi, are you getting in the answer? Memuna, are you getting it?
Yes, sir.
How much it will be? Tell me quickly. So 98 gram per mole is the molar mass. So moles of H2SO4 is equal to 0.5 moles. You took only half the quantity. Okay. So number of, so you don't want molarity, you want equivalents. Okay, you want normality. So number of equivalents will be equal to moles into the multiplication factor. Okay, or which tell us that 1 mole will give release how many moles of that effective thing, H plus ions or OH minus ions or electron. That is called N factor. Okay, so that N factor, okay, moles is half mole only you took, but that N factor is how much? Okay, that is 2, because this 1 mole is giving 2 H plus ions, so effectively it is effective equivalent to 2. Okay, so it is actually how much? 1 equivalent. Okay, these are the moles into N factor equal to equivalent. So this is 1 equivalent per liter, right? So it is 1 normal solution, right? So moles we can't equate directly. We may equate, suppose if only 1 H plus and 1 OH minus is given. For HCl and NaOH, if you take mole, it is good. But if you are reacting NaOH with H2SO4, then you can't equate the moles, because H2SO4, each H2SO4 is going to give you 2 H plus ions. And one NaOH is going to give you 1 OH minus. So mole definitely are not going to be same. The equivalents are going to be same. So there you talk in terms of equivalent. That's it. Clear? So this is the basic idea of normality. So the time is already up, and let's cover it on the next one. And do let me know your problems, or if you need to do something more. Okay, just like Mamuna told me just now, that's good. Okay, and any doubt, don't hesitate to ask anytime. Okay, so let me end today's class. Right? Bye bye, everyone. Take care. Good night.
Thank you, sir.
Okay.
Thank you, sir.
Okay. Bye, everyone.